Hey, this is Gary, and in this video we're going to work with the GDX input features and integrate that into our 2D game framework. And so we'll start by creating a new screen for us. We'll just call that input screen, and that will extend the base screen. Now I made a change to the base screen to no longer take the height and the width because we weren't using those for anything. And that's because in the base screen we set a default width and height 800 by 600, and that's set by the camera, and that's reflected when the screen gets created. And so we can use the resize feature to change those dimensions. So back in our input screen, so we'll update the background color to white, and in this example we're going to use a new animation class called block animation. This block animation will use a single pixel white image to produce a block texture of whatever color that we update it to and whatever width and height we set. So this is a simple, easy way to create a rectangular shape on the screen. LibGdx also has a shape animation feature for creating more complex animations or having an outlined rectangular shape or an elliptical shape as well. So we'll add that block animation to our class, and we'll create a 20 by 20 block animation, and then we'll create an X and Y coordinates, and then we're just going to draw that animation at our X and Y coordinates. And so the default of that is actually going to be 0. And we'll update our game tutorial with the new input screen. And then one other thing we need to do is set a color for our animation. So you saw how we added the ability to set colors to animations in our previous video. And so here we have our blue block 20 by 20 at 0, 0. So the first thing we're going to do is look at GDX, and in this class it has a static reference to input, and then you can get delta X, delta Y, the max pointer rotation, X and Y. From the input, you can also do accelerometer, X and Y and Z, gyroscope, X and Y and Z. So different types of input devices will use these other methods. And a lot of these methods are related to some type of gamepad, which I don't. I'll just cover the basic kind of keyboard and mouse functionality. So the X and Y here are related to the mouse input. So we'll just do set X and Y, and then Y we'll set it to the Y input. So then you can see there it is. Now you notice that the Y is reversed, and that is because the input is based off of the top location on the screen. And so here my cursor is at the top, 0 essentially, but OpenGL renders from the bottom up, and so it would be here. And so that's why it is reversed or flipped from what we expect. So we have to make an adjustment so that it renders at our correct cursor position. So what we'll do to reverse that Y coordinate so that it renders correctly, we'll add a class called screen input. And this is just a convenient helper class to reverse that Y location from the input. And so here in our screen input, we'll have the width and the height, which is the width and height of the screen that will get passed in when this is set. And so in our base game, when it's created, we set the height and the width to our screen input. And then if they do a resize, we also reset that, just like we do with the camera. And so that way our height and width will be correctly. And then the get input X just calls the input get X. The get input Y will take the screen input's height, and then we'll subtract the input's Y location. So to use that, we'll just do our screen input, get our X input, and then get our Y input. So I've added an input X and input Y, the main reason being that instead of having you call X one way and then call Y a different way, this kind of simplifies it so you're calling them both from the same context, and so you kind of get the idea that okay, these work together. So now with that updated, you can see now it's the block is following the cursor, and you can see it's now pointing to the bottom corner for that location, and then you can see it renders off the screen as you go off the screen, and then if you come back in here, it pops down there. Okay, now we're going to take a look at one of the other input methods. So we're going to go back to our GDX input. We're going to look at get delta X, and then we'll also do the get delta Y. And then we're also going to set these to 100 to kind of better illustrate how this delta works. And I'm also going to make another block animation. We'll set that to dark gray. And we'll set that at 100, 100. And then we'll show you how the delta works. So here we have the blue box. The dark gray box is underneath it. And the way it works is it checks the mouse movement and compares it to the last time the method was called to get the difference between your mouse movement. So when you move over, you can see it moves slowly. If you move the mouse slowly, if you move the mouse quickly, it'll also move quickly. And so this is if you just need the difference between the last time you executed the get delta. So if you're like making a first-person shooter, you can use this for controlling the background. You have slow movement, fast movement, that type of situation. And now I've added that to our screen inputs, and so for the Y, you notice that it was reversed, and so I just do a negative off of that, so then it puts it in the when you move the mouse up, the block will also move up. And so now I'm going to call my screen input get input delta Y, move up, move down, move up, down, until the box moves in the same direction the mouse does. So the next piece we're going to look at is the mouse buttons. So create a boolean here, and then so there's two entries here: is button just pressed and is button pressed. Is button just pressed only gets fired on the initial press of the button, and then is button pressed is as long as you're pressing that button, it will return true. So look at is just button press. And so for the particular buttons, we need to go to the input class, and there's a button class, and then you can choose either the left mouse button, the middle button, the right button, or the back and forward buttons if your mouse has that. So we'll just do the left mouse button. And so what we'll do is we'll create an if statement that if the button is being pressed, we're going to update this counter, and then we'll just output the counter value here. And so we'll see that in the console output. Alrighty, so press the button. Now if you're outside the window, obviously it doesn't register that you've clicked on the button. So if you're up here in the heading bar, it also doesn't register. Just while you're in the screen does it pick up. And now we'll do just the button pressed, and we'll also do the left button. And so here we'll press it. So see, I've held it for a while. As long as I hold it, it'll continue to count up. And that's how the button input works. And so you can trigger events off of button clicks. And so now I've tied the button click with the getting the X and Y coordinates. On screen input, I updated these methods. I removed the input from the method names, made them much shorter. And so it sits at 0, 0 until I click the button. And so now you can activate the X and Y coordinates based off of whether or not the button is clicked. That's the button pressed action. Also in GDX, there is a get X with an integer, and the integer is for cell phones, touch screens, and the integer is the number of fingers that are being clicked, which one you want to respond to. So this is 0 based. The get X itself will respond to single clicks with the finger, with one finger. If you want to do 2 fingers, you'd have to do get input 1, because it's 0 based index, to get its X coordinate, and likewise the Y coordinate. Also there is the get delta, which also has the finger index associated with that. So now we'll look at the method for getting key inputs, and so that is the is key pressed and is key just pressed. So look at the is key pressed, and here we use input, the keys class, and then the key value that you want to react off of. So for example, let's do the B key. And so we could set our Boolean to that. Now if I press the B key, you can see it's now responding, and it's going to the cursor location like we did in the previous example. And then if we just did the other method, is key just pressed, and let's just use A. And so here if I press A, you can see it flashes real quick. Even though I hold down the A key, it's just getting the initial click of the A key. One more thing I want to look at with the inputs is the get input text input, and there's an input text listener, and you could specify the heading, the default text, and the hint text. And what that does is that brings up a window, text input window. So here it is. So you can see the hint text and the default text are over there, and it creates this window with an OK and cancel button. So if we turn off our default text, and there you see it shows the hint text. So if I type something in here and click OK, it returns that, prints that out. So here's where it goes to the input, and it'll print out, or I have it so it'll print out what was typed in. And if you click on cancel, it will just close that window. So I'll demonstrate that cancel real quick. So cancel, so there it goes. It just executes the cancel method. So this is convenient to have a text input text screen. It doesn't exactly in line with maybe what you'd want for your game, and so there will be better ways that we can do this text input box. So now we want to take our inputs and then integrate that into our framework and have that linked to our motion classes. This is our movement interface, so it's in our movement package. And we have our update method, which takes the delta time, like in our other update methods. And this method is where it determines, based on either a movement or the elapse of time, it determines what the distance and float pixel distance on how far it moved. And then you would get that distance through either the get X update and get Y update. And you can also set a speed to this movement, to how fast it should move. And one more method that we'll use is a get direction that will return the direction from 0 to 360 for that movement. The next class we have is the base movement, which implements the movement and has the basic attributes that are associated with movement, those being the X and Y update, a direction, and the speed of the movement. And these are the getters for get direction, X update, Y update, and then setting the speed. And this is the calculate magnitudes by direction, a convenient method that takes the direction and the update speed. Normally the update speed when you're moving would be the same as the speed set here. If you're not moving, that would be 0. And so if it's 0, your up and your X and Y updates would be 0. If there is a speed, then it will convert your direction into radians, and then it will get the Y update based off of the sine times the speed, and the X update will be based off of the cosine of the radian times the speed. Here is the 2-key movement, and so this is a movement that's based off of 2 keys. And so we have an int for the key IDs, int array, and whether or not it's vertical or horizontal. And so our constructor will take key 1 and key 2, and whether or not it is vertical or horizontal. And so if it's vertical, key 1 is up, key 2 is down, horizontal, key 1 is right, and key 2 is left. So we set those attributes, and then in the update method, if the first key is pressed, essentially key 1, and if we're going vertical, up, the speed will simply just be the Y update will be what the speed is, and then we'll set the direction to north so that the motion can use that. Otherwise it's horizontal, and then the X update is the speed and the direction is east. And if the key 2 is pressed, if it's vertical, our Y update will be minus speed, so it will go down, and direction is south. Otherwise our X update will be minus speed and direction is west. And if those keys are not pressed, we go to the else statement. We set our X and Y update to 0 and our direction to no direction. So now we'll go into our input screen and we'll demonstrate that. First we need to create a private 2-key movement. And we also need to use our two-way motion. And we also need to keep track of our X. We'll start at 100. And our Y will also start at 100. And then here for our movement, create a new 2-key movement. And we'll use the input keys. And we're going to go for right. And here we'll do input keys for left. And we're not doing vertical, so we'll pass in false. And we need to set our speed. We're going to set our speed to 0.8 pixels per second. And then we'll create our motion. Then we'll get our texture, which is our JoJo running. Which is 50 by 62. Duration of 0.2. And it's 1 and then 0. Here we do our movement, and we'll call update based on the delta time. And we'll call our motion, and we'll do update and the delta time, and we'll get the movement, get direction. And what we'll do here is x is going to equal to x plus our movement, getting the x update, and our y will equal y plus the movement, getting the y update. And the motion, we're going to draw it based on those x and y locations. Okay, and we'll run it. So it's defaulting to him running to the east. So I press the left key, he'll move in the other direction, and he's running in the opposite direction. And pushing the right key, he goes right in the right direction. And that's how simple it is now to implement key movements. These methods right here is all that we need to call. And that makes it a lot simpler. We don't have to do all that complex logic that we did when we did kind of the movements before, calculating our direction, updating everything. That's pretty much all encapsulated into our new classes. So now I'll demonstrate moving up and down. So I'll just copy this. We'll set this to true. The first key is going to be our up. And the second key will be our down. And we'll set our motion, set our horizontal to false. And that's all we need to do. And then just run it. So if I hit the up key, he goes up. And if I hit the down key, he goes down. And the next class I have is the 4-key movement. And this is for moving in 4 directions based off of 4 key inputs. And so we have our int array with our key IDs. And I have this multi-boolean. I'll explain that in a moment. This is our basic constructor for the 4 keys. You put the key ID for going up, down, right, and left. And then this is the 4 keys for going up, down, right, left, and multi. And here in the update method, if it's multi, it will call the multi-update direction. Otherwise, it calls the simple update direction. So I'll go over the simple update direction first. So in this case, if you press the up key, it will set your speed to go up, your x to 0, and your direction north. And this is the south key, so the y will be minus the speed, direction south. This is the east key, the right, which will go, x update will be the speed, y update will be 0, and your direction will be east. And this is the west key, or the left, so your y update will be minus your speed, and direction is west. Otherwise, it'll have an update of x and y of 0. And the direction will be just based off of what the previous direction was. Now the multi-update direction, this is for pressing 2 keys at once. So if you press the up key or the right key, northeast, so it'll calculate your magnitudes by direction. Using this method, we'll calculate the distance moving that speed in that diagonal direction. And here, if you're pressing the key up and to the left, this will be northwest, and it'll calculate your magnitudes that way. Otherwise, if you're pressing the up key, it will just go north, like we saw up above. And this is for the south, the downward directions. So if you're pressing south and the east key, the right, it'll calculate that distance at an angle. And if you're pressing south and the left key, or west, it'll calculate the direction at an angle that way. Otherwise, if you're just pressing the south key, it'll move south. And if you're just pressing the east key, it'll move to the east or the right. And if you're pressing the left key, it'll move to that left direction, west. Otherwise, it'll set your update to be 0. All right, I'll show you how that works. So I'll create a new 4-key movement. And I'll use the 4-way motion. And so for our movement, for 4 keys, we'll create a new instance of that. we'll use the constructor that takes the multi, and I'll demonstrate that a second. Get our key for going up. Get our input for going down. Get our input for going right. Get our input for going left. And we'll set our multi to false for our initial demonstration. And we'll set our speed. We'll set it to 0.8. Now for our motion, our four-way motion, we're going to use this constructor here. Get our texture, which is our demo character, and he is a 64 by 64, and duration 0.2. So that's frames, or that's row 3, 2, 0, and 1. And then down here, we'll comment out these statements. And here, we'll do our movement, do an update, do our motion, also do an update. That's movement 1, .get direction. And then X and Y updates are going to be based off of movement 1. And our motion 1, we'll draw that at the X and Y location. Let's run that. Okay, here's our character. So if I move to the right, move to the left, moving down, moving up. So if I press the right and left, you see it goes either right or left depending on if I let go of the up button. And which one takes precedence is based off of the order of our if statement. So now I'll show the multi-key function. Just set this to true. Come back into here, run this. Again, up, down, right, left. I hit up and then the right key, and you see it's moving at an angle. Now she's moving right, and then the right and down key, also moving at an angle. Just the down key, down to the left, just left, and then up to the left. And you see how smooth that is, and how the movement mirrors the straight movements. So it's not exponential or anything like that. So the movements are consistent, even if moving diagonally or just up. And so again, you have 5 simple lines for doing your movements now, because everything else is encapsulated into our framework. So that's going to do it for this video. Be sure to subscribe and like. And next video, I'll cover some more movements and integrating this into the actor class. All right. See you in the next video.